Hi everyone. Okay, so now we are on chapter 7, section 7.3, and this is where we left off on the PowerPoint slides. So make sure you find the slide in your notes, and this is where we will start. All right, so this section is on percent composition, and then plus I'm also going to teach you empirical formulas and molecular formulas. We are going to begin with percent composition. How do you find percent composition of a compound? So basically, percent composition is just like any other type of percentage problem. So to find percentage is part over whole. Okay, whatever part you're looking for, that goes on top over the whole thing. And then, of course, you multiply it by 100 to get it into the percent form. So as you can see that what's written here says the percent mass of element E. So if you're trying to find the percent of element E, then that's why element E goes on top over the mass of the entire compound. Okay, so now let's do a sample problem. An 8.20 gram piece of magnesium combines completely with 5.4 grams of oxygen. So let's just underline those pieces of information. So 8.2 grams magnesium, 5.4 grams of oxygen. And it's asking, what is the percent composition of this compound? And when it's asking for the percent composition of a compound, that means you need to find the percentage of each of the elements, okay, that is found in the compound. So we need to find the percentage of magnesium, and we need to find the percentage of oxygen. Okay, so we're going to use our concept of part over whole. So let's see, the part of magnesium is 8.2 grams, and that has to be added with the 5.4 to give us the total. Okay, so we're going to add both of them up together to get the total, so part over whole, and that equals 13.6 grams. And then we multiply by 100 to get that into the percent form. And we're going to do the same thing for oxygen. So oxygen goes on top, and that has a mass of 5.40 grams over the whole thing, the total, 13.6, and then times 100 to put it into the percent form. So put this into your calculator, and then for the magnesium, you should get 60.3%, and then the oxygen, you should get 39.7%. And when you add all of them up together, it should equal 100%. So that is one way you can check your work. This is another example of a percent composition problem. So you can see in this particular problem, it doesn't give us the grams for carbon or the grams of hydrogen. It just is asking us to calculate the percent composition of C3H8. Okay, so when it's presented in this form, you still need to find the percentage of each one, so percent of carbon, and we still need to find the percent of hydrogen. Okay, so this time we're just going to look at the chemical formula and we're going to use our periodic table. So you need to get out your periodic table. Okay, so let's do carbon first. Notice there are 3 carbons. So find the mass of 3 carbons. So if you find carbon on your periodic table, it should have a mass of 12, and there's 3 of them. So that means 12 times 3 is 36. So 36 grams on top over the mass of the entire thing. Okay, so let's mark that on our paper here. We said that the C3 was 36, and let's add the 8 hydrogens to that. And if I do my math right, let's see, 8 plus 6 is 4. So it should be 44, right? Okay, so then that goes on the bottom here, 44 grams. And then you're going to multiply by 100 to get that into the percent form. All right, then we're going to do the same thing for hydrogen. So the mass of hydrogen, well, there's 8 hydrogens, so 8 times 1 is 8 grams, over the mass of the whole thing, which is 44, times 100. All right, so you put these into your calculator, and then you should find that the carbon percentage is 81.8%, and your hydrogen percentage is 18.2%. And then you can always double check. These two added together should equal 100%, and they do. So that is one way you can check your answer. Now we're moving on to empirical formulas. Yay! All right, so empirical formulas are basically the simplest whole number ratio. So I have 3 examples here, and what we're going to do is we're going to fully reduce the subscripts, okay? When all the subscripts are fully reduced, that is what we call the empirical formula, okay? So then, for an example, H2O2, so those 2's can still be fully reduced. You can divide by 2 on each of them, and then it becomes HO. The N2H4, the 2 and the 4, those can still be reduced down. Divide both of them by 2, right? And then it becomes NH2. Sometimes the empirical formula and the molecular formulas could be the same, all right? So in this case, CO2 is already fully reduced, so it's going to stay CO2, okay? All right, so now let's do an example of an empirical formula question. Here is an example of an empirical formula question. So let's see, we have 25.9% nitrogen and 74.1% oxygen. So let's say, for an example, you're out hiking and you find this mystery substance, and you take it back to your lab at home, because we all have our own personal lab at home, and you analyze it, and these are the percentages that it gives you. It tells you that this mystery substance contains that much nitrogen and this much oxygen. So what we want to do is we want to find out what this mystery element is. So the first step is to convert to moles. And if you add up these percentages here, you'll see that they add up to 100%. So to make our math a little bit easier, we are going to assume that we have a 100-gram sample, okay? That we have a 100-gram sample. So then I'm just going to say then, if we have a 100-gram sample, then that means we have 25.9 grams of nitrogen, okay? And that we will have 74.1 grams of oxygen, because 25.9 over 100 is 25.9%, and the 74.1 grams is over 100 will give you 74.1%. So that's why we assume that we have a 100-gram sample, okay, to make our math easier. So in other words, whatever the percentage is, we just say that those are grams there. All right, so now we're going to convert to moles. So you should already have your periodic table out. So remember, anything with grams in it, we're going to use a periodic table and use the molar mass. So if we have grams here, then we want grams on the bottom of the next step. Okay, so I'm going to put grams there, and that's going to be over 1 mole. You look up nitrogen on the periodic table, and it is 14 grams per mole. Look up oxygen on your periodic table, and that one is 16 grams per mole. Okay, so divide in your calculator, find the mass here. So for nitrogen, that should turn out to be 1.85 moles of nitrogen, and then this will equal 4.63 moles of oxygen. Okay, that is your very first step, convert to moles. Now I know on the next slide I have step 2 and step 3, but I'm actually just going to do step 2s and 3s all on this slide because it's easier to show all of the work. All right, so then the next step is to determine the lowest whole number ratio. Okay, determine the lowest whole number ratio. So in order to do that, we're going to take a look at both of these answers, 1.85 and 4.63. So you're going to divide both of those numbers by the smallest one. So 1.85 is the smallest number, so we're going to divide this one by 1.85, and we're going to divide this one by 1.85. This will give us that lowest whole number ratio, or what we call the simplest whole number ratio. So then this will equal 1, and this will equal 2.5. Okay, so what this is basically saying, it's saying that we have 1 nitrogen and we have 2.5 oxygens. All right, 2.5 oxygens. But we don't like to see the fractions here. We don't like to see a fraction here. We like to have whole numbers here. So we're going to multiply this whole thing by 2 to get rid of that fraction. Okay, to get rid of the fraction because we want a whole number. So therefore, your answer would be N2O5. Okay, and that would be your empirical formula. So if this number here turns out to be close to a half, keep the half in there. Sometimes the number might be like 1.99. If it's like 1.99, you can obviously round that up to 2. Okay, or if it's like 1.01, you can round that to just 1. But if it's something close to a half, keep the half in there, and then in the end, just multiply it by 2 to get rid of the fraction. All right, so then, once again, the answer to this would end up being just N2O5. So I already showed all of the work on the previous slide, so if you wanted to just fill it in here, you could. I just like to do everything all together so you can kind of see what it would look like if you were to do the work all together. Okay, so now we're moving on to molecular formulas. This is the very last concept for this section, okay? Molecular formulas. So remember, empirical formulas are the simplest whole number ratio. Molecular formulas are basically a multiple of the empirical, okay? So this means that the subscripts are not fully reduced, okay? The subscripts are not necessarily fully reduced. So in this particular problem, they already give us the empirical formula right there, and you can see that the subscripts are fully reduced, okay? And what we want to do is we want to calculate the molecular formula of the compound, and it has to equal a mass of 60, okay? So in other words, we're trying to figure out what do we have to multiply this whole thing by so that it equals 60 grams, okay? And in order to do that, you need your periodic table. Find the mass of CH4N. So if you find that on your periodic table, carbon is 12. That's going to be a total of 4, right? Because 4 times 1, and your nitrogen is 14, right? So that equals 30 grams. So 30 times what is going to equal 60. That is what we're trying to find. So this one is pretty easy for you to do. It's going to be a multiple of 2, right? 30 times 2 will give you 60. So then you're going to multiply all of the subscripts in here by 2. Therefore, your answer will look like this. Okay? It will look like that. C2H8N2. All right? And that is your molecular formula. So remember, molecular formulas are multiples of the empirical formula. Okay? So empirical formulas are fully reduced. Molecular formulas are not necessarily fully reduced. All right? And that is everything for 7.3. All right? Good night.